All right, so ways to fill out the unit circle. We've talked about kind of different methods that you can do to memorize. So in quadrant 1, there are 3 coordinate points within quadrant 1. These 3 all have coordinate points with denominators of 2. So I like to kind of just go filter those in. Inside, so starting with the x value and working my way up, 3, 2, 1. Outside, so starting with the y value and working my way up, 1, 2, 3. Obviously, you can work on any way that you want to memorize it. Maybe you go like 31, 22, 13. You think about them as like numbers, right? Think about some sort of method that works for you, and then use it to memorize those coordinate points. Now, all of those numerators are going to get square roots except for the 1, because square root of 1 is just 1. So it would be a waste of time to write a square root over the 1. So the 2's and the 3's get square roots. All right. So quadrant 1 contains 3 angles from smallest to biggest. That's 30 degrees, 45 degrees, and 60 degrees. And in radians, you can either memorize what they are in radians, or you can divide by 180 and simplify the fraction, because that's how you go from degrees to radians. So this is pi over 6, pi over 4, pi over 3. Everything I'm writing on the board, you have to be able to fill out on your own.
And we're going to do tangent today, right?
Today we're going to do the tangent of those, yep. All right, and then in Friday's class, we did the corner points, which I think you already knew. We were just filling in some new data, right? So this angle right here is 0 degrees if I don't move, but if I do a full circle, it's also 360. All right, so either of those. And then in radians, that's 0 and 2 pi. And then if I head up here, this is 90 degrees. And if I divide that by 180, that's pi over 2, or you can call that 0.5 pi. That's the same thing. I don't care how you look at that one. 0.5 pi or pi over 2. If I go 90 more degrees, I'm at 180, which is the same thing as pi. And then 90 more degrees is 270, which is the same thing as 3 pi over 2. You can call that 1.5 pi if you want to just go up by 0.5, so that works as well. And then I'm back to 360 and 2 pi, which is the full circle. We talked about how Friday, like the coordinate point is right here. And this point is going over the radius of the circle. And since it's a unit circle, the x value of that is 1. And this x value, or this point, is on the x-axis, which means it doesn't go up at all. So that coordinate point is 1, 0. This point right here is going up the radius of the circle, so the y value is the radius of the circle. It's not going left or right at all. The x value is 0. This point right here is going left the radius of the circle, so that's an x value, but it's going to the left, so it's actually a negative 1. And that point isn't vertical at all, up or down, so the y value is 0. And then this point right here is going down the radius of the circle, so it's a y value, but because it's down, it's negative 1, 0. So red is what we did a majority of last week. Blue is what we did on Friday. That was the corner points. All right? And then you can take that unit circle and you're going to answer a series of questions. I think for warm-up I said we're going to do 1 and 5. So just for time's sake, let's take a look at 1. Right? So when you are solving a problem using the unit circle, the first thing you want to do is get the trig function alone. So I would divide out the 2. Cosine of theta equals root 3 over 2. And then we talked about how on Friday, sometimes our answers end up in a quadrant and sometimes they end up on corners. If I get the trig function alone and I get a 1/2, a root 3 over 2, or a root 2 over 2, I'm ultimately going to have 2 answers at the end of my problem. But if I get the trig function alone and I've got a 1 or a 0, I might not have two answers. So it's just you knowing the difference between when do we have to do a lot of work and when do we not. So because I get a root 3 over 2, I'm going to have to pick two quadrants. Now this fraction itself is positive. So because it's positive and not negative root 3 over 2, I would pick the quadrants where cosine, because the problem's cosine, is positive. And cosine is positive in 1 and 4. And then I would use my unit circle to find my reference angle. To find my reference angle, I'd be looking for where is x root 3 over 2. I would change my question to where is y root 3 over 2 if the question was a sine question. Sine is y values, cosine is x values. So let's go back to our unit circle and look at the red ones. Where is x root 3 over 2? 30 degrees. So my reference angle is 30 degrees. I'm going to apply 30 degrees to quadrants 1 and 4. You can draw a picture or not. You can use the rules, right? In quadrant 1, the red angle and the green angle are the same. So quadrant 1, the reference angle and the standard angle are the same. My answer in quadrant 1 is 30 degrees. In quadrant 4, if I were to draw a triangle here, this is 30 degrees. I want this. So my green plus 30 is a full circle. So then that green must be 360 minus 30, or 330. My answers are the green angles. All right, if you get something 1/2 root 3 over 2 or root 2 over 2, something in quadrant 1, something that contains these red numbers, you should get two answers at the end of the problem. Obviously, we could do the other ones too, but for time's sake, I'm just doing one refresher, all right? And then I'm going to do one more in radian mode, so I think I picked 5. All right, so if I were to look at number 5, and I wanted to get the cosine alone, the first thing I would do is subtract 7. Divide by 5. I can't do an all students take calc here because 0 isn't positive or negative. 0 is just 0. This is not a root. Is this problem different again? All right. Some of you are looking at me like I have 5 hats. All right, so this is not a root 3 over 2. This is not a 1/2. This is not a root 2 over 2. If it's not something in quadrant 1, it doesn't have a reference angle. Okay? This is a corner point. Zeros and ones fall on the corner. And if it falls on the corner, it's not in a quadrant. And if it's not in a quadrant, then you can't make a triangle. And if you can't make a triangle, then you don't have a reference angle. All right, so there's no reference angle here. All I'm going to do is look at the circle for x, because cosine is x, equals 0. Sometimes you get one answer. Sometimes you get two answers. Sometimes you get 3 answers, okay? There's no set rule here. It's just look at the circle. Look on the edges and look at the x values specifically. So I'm looking for an x value of 0. This has an x value of 1, so it's not that one. This has an x value of 0, so it's that one. But I want the pi version because I'm in radians for the directions. This has an x value of -1, so I don't want that one. And this has an x value of 0, so I want that one too. And I'm going to do my answers in terms of radians. So I'll call this pi over 2, or maybe you call it 0.5 pi. And 3 pi over 2, maybe you call that 1.5 pi. Corner points are a little easier. Just look at the circle, pick your answer. If it falls within a quadrant, that's a little tougher. You're going to have to do some work. All of that was a summary of last week. Today, what we're going to do is tangent. All of the examples you've done so far had cosine, sine, cosecant, or secant. No tangents, no cotangents. That's because sine is y and cosine is x, which leaves nothing for tangent. Right? There's no more like, it's not x, y, z. It's not a 3D grid. So there's no like z is tangent. You have to solve for tangent. Okay? So in your toolkits, tangent is on page 8. I'm going to show you how to physically solve for tangent. Some of you will solve for tangent every time, and some of you, just like the rest of the unit circle, are just going to memorize this. Okay? So I'm looking, is this page 8? My pages are off. All right, let's go. What's that? Oh, I'm looking at the wrong thing. Oh, sorry. Listen, I was doing the same thing. All right, it is page 8. All right. So when we solve for tangent, we're going to do opposite over adjacent. And when I'm thinking about triangles, opposite is so, S-O, so that's sine. And adjacent is the co, that's cosine. So to find the tangent, I'm going to do sine over cosine. Well, sine is y, and cosine is x. So to find the tangent, I'm going to do the y value divided by the x value. I have to take the coordinates. I can't just simply pull them now. I've got to divide them. So if I were to find the tangent of 0 degrees or the tangent of 2 pi, they're the same thing, right? 0 degrees and 360 are the same thing. So 0 pi and 2 pi are the same thing. This is the same thing. So if I want to find the tangent here, I have to think about what the coordinate point is here. I'm going to go back to my unit circle that we filled out earlier. The coordinate point at 0 and 2 pi is 1, 0. So I'm going to take the coordinate point, which is 1, 0. I'm just pulling that right from the unit circle. And to find the tangent, I'm going to do the y value divided by the x value. So the tangent at this place is the y value divided by the x value. What's 0 divided by 1? Remember, we don't have a calculator. 0 divided by 1 is 0. The tangent of 0 is 0. That one's pretty easy. All right, let's keep working our way around the picture here. So the next one says, well, then what's the tangent of 30 degrees or pi over 6? They're the same angle, all right? So let's go back to the unit circle and let's look at 30 degrees or pi over 6. Here's the coordinate point. Root 3 over 2, comma 1/2. All right, so we're going to divide them. Y divided by x. That doesn't look fun. Have you guys ever or remember keep, change, flip? When you're dividing fractions, you keep, change, flip. So I'm going to keep the top the same, change the division in the middle to a multiplication, and flip the bottom fraction. Dividing fractions is keep, change, flip. Keep the top, change division to multiplication, flip the bottom. Once you do that, you can multiply straight across. So it's 2 times 1 is 2, and 2 times root 3 is 2 root 3. What happens here? The 2's cancel out. And I have 1 over root 3. What do you think I got to do with that? I got to rationalize it. I can't have that root in the bottom. So I've got to multiply by root 3 over 3. Told you guys you weren't going to enjoy this. All right? So 1 times root 3 is root 3. And root 3 times root 3 is root 9. So the tangent of 30 degrees is root 3 over 3. Now you can choose to work out the math every time. Right, you'll have your unit circle, you can do y divided by x, keep, change, flip. Or you might see, like, I can just memorize the tangents too. Just like a few more things extra. So you might want to memorize that eventually. That's going to be your choice. We're going to work through them all so you know how to do it, and then you can either work through it or memorize it. All right, so I keep going through the circle. 45 degrees, or pi over 4, has this coordinate point. And to find the tangent at that coordinate point, I'm going to do the y value divided by the x value. So the y value divided by the x value. Or keep, change division to multiplication, flip. 2 times root 2 is 2 root 2. 2 times root 2 is 2 root 2. What's 2 root 2 over 2 root 2? 1. The tangent at 45 degrees is 1. That makes sense because the x and y values are the same. So I'm going to divide a number by its exact self. 5 divided by 5 is 1. 10 divided by 10 is 1. So root 2 divided by root 2 divided by root 2 divided by root 2 is also 1, even though it looks a little funkier. All right, so that's the tangent at 45 degrees. We're going to keep going around the circle. So now if I'm at 60 degrees, here's the coordinate point. So tangent is y divided by x. And if I want to do that mathematically, I keep, change, division to multiplication, and flip. And then I multiply straight across. 2 times root 3 is 2 root 3, and 2 times 1 is 2. The 2's cancel out. So the tangent at 60 degrees is root 3. You have to calculate the tangent, y divided by x, or memorize the tangents. You'll see there's not that many to memorize if you choose to go that route. All right, so 90 degrees or pi over 2, that's the same angle. One's just in degree, one's just in radian. The coordinate point there is this. If you physically had a unit circle in front of you, all right? So I am going to do the y value divided by the x value. Can we divide by 0? All right. Does not exist. There is no such thing as the tangent of 90. If you had a calculator and you typed in tangent of 90, you'd get an error. You can't take the tangent at 90 degrees. I'm just abbreviating it. Does not exist. If you want to write like error, fine, that works. Okay. So filled out for you up here is the unit circle that we did earlier. I just didn't want to fill it again. What I left out was the tangents. Here's what you might end up doing. I just wanted to show you, like, you might just say, I'm going to memorize the tangents. So the tangent at 30 degrees is root 3 over 3, 1, root 3. So you might just decide, like, that's really not that hard to memorize, and I'm just going to memorize it. Or you're going to fill out your unit circle, and you're going to do the y value divided by the x value, and you're going to figure it out. All right? Here, the tangents are both 0. They are the same on the opposite side. And here, the tangent does not exist and does not exist. So whether you choose to memorize the stuff I just wrote in green, or you'll take the coordinate point and do the y value divided by the x value and work it out to find the tangents. So we're going to apply that to some examples here. I don't know what the directions say. Is there directions? Does it say like 0 to 360 or nothing? All right, so we're going to go degree mode. All right, it doesn't have directions, so we'll just go degree mode. So first thing I'm going to do is get the tangent alone by dividing by -10. So I have that the tangent of theta is -1. I have to decide, is this a corner tangent? Because if it's a corner tangent, then there's no reference triangle, meaning there's no reference angle. Or is this a quadrant tangent? So I'm looking at my greens to find not -1, because that's not there, but the positive one. You okay with that so far? This is not a corner tangent. Corner tangents are 0 and does not exist, okay? This is a quadrant tangent, which means I'm going to have 2 answers. And I got to figure out which quadrants those 2 answers are going to be in. Which quadrants are they going to be in? Tangent is -1. S or C, right? It's positive in A and T, so it's going to be S or C. And then I need to find my reference angle. So where is tangent? I'm not going to find where it equals -1 because that doesn't exist on my circle. I don't have negatives because I only have quadrant 1. Everything's positive there. But tangent is +1 here. And that's 45 degrees or pi over 4. The directions didn't say, so we'll just go with 45. And then once you have your reference angle, you'll apply it to the quadrants you picked. We picked quadrant 2 and quadrant 4. So in quadrant 2, we'll do 180 minus 45. And in quadrant 3, we'll do 360 minus 45. Just keep in mind we don't have calculators when we're doing these. Right? So I'm just doing this math vertically. I'm going to borrow from this. 10 minus 5 is 5. 7 minus 4 is 3. So this first angle is 135. I'm going to borrow from this. 10 minus 5 is 5. 5 minus 4 is 1. So this second angle is 315. The process of everything I just did is no different than what we did last week. It's just last week, to find the reference angle, I was simply looking at an x value or a y value. Now I have to look at the y divided by the x. Let's see if we can get one more of these in, or at least quickly. So if I'm going to do 65, let's just do this one in radian mode to switch it up, all right? I don't have to get tangent alone, it's already alone. Is root 3 a quadrant tangent or a corner tangent? Where do you see the root 3? In quadrant 1 or on the corners? It's a quadrant tangent. So I'm going to do I'm going to pick where tangent is positive because that's positive. I'm going to find the reference angle directly from the circle because I'm not looking at an x value, I'm not looking at a y value, I'm looking at the tangent, and I did the tangents. Tangent is root 3 at pi over 3 if we're doing this one in radians. 60 degrees if we're doing it in degrees. Quadrant 1 is pretty straightforward. The answer is just pi over 3. Quadrant 1 is the same. Quadrant 3, we're going to do pi plus pi over 3. As a reminder from last week, if I want to do this math, I need the common denominator. So I got to give this a denominator of 3. Which means I have to give it a numerator of 3 as well. So that's 3 plus 1, so that's 4 pi over 3. I threw a lot at you today because I wanted tomorrow to just be time where you practice tangent problems on your own. I didn't want to give you any notes tomorrow. So I wanted to get the notes out of the way. So tomorrow, we're gonna just work with tangents. You'll fill out the circle, you'll do practice problems, you'll check your work. Wednesday will be a quiz review day, all of it together. Thursday is your quiz. Thursday's your long block with me, so you'll have the full hour.
Am I coming in tomorrow?
Up to you.
I'll be here.
You wanna come in? What time are you thinking?
I already came in today. I could do it tomorrow. How long do you have?
You have the whole block, so it's just up to you. I mean, I don't know how long it'll take you.
Probably just like 4 or 5 minutes.
Okay.